Science Research Methods Project by Liana Fite, Ziva Landa, Harry Troy, Carmel Reyes, and Kobe Sokolic.
We chose to research this topic because we're all aware of this humanitarian crisis around the world surrounding water and realize how fortunate we are to be able to have access to as much clean water as we want. We tried to do research that is interesting and applies to the real world.
And our research question was, which portable water purification method is most effective and why?
Contaminated water contains a variety of toxins that can cause severe health issues. Common contaminants include iron, copper, and other metals, as well as chlorine, nitrate, nitrogen, and other chemicals. One of the filtration methods that we chose to use and experiment with was a P&G powder. This filter works in 3 steps: coagulation, where clumps are formed; flocculation, where the clumps of chemicals and other pollutants become wrapped together and form larger clumps; and disinfection, which uses very little chlorine inside the powder to get rid of any other bacteria or chemicals left inside the water.
The Sawyer Mini Water Filter is a small handheld filter that has several layers of microscopic mesh that when the water goes through, it takes out any contaminants and toxins in the water, or hopefully takes out any contaminants in the water. It can remove molecules as small as 0.1 microns in diameter, which are the majority of contaminants found in the water. And our third method of filtering water was boiling, which is a common and cheap method to filter water. When the water is 100 degrees Celsius, no organisms or bacteria can survive in the water, so they cannot harm you if you consume them. We predicted that the Sawyer Mini Water Filter would be the most effective at cleaning the water because it has a physical barrier, microscopic mesh to remove contaminants. The other filters attack the water chemically, which we believed wouldn't be as effective. Our materials included our 3 filters, which were Sawyer Mini Water Filter and P&G powder, and then also boiling water. Tap water as our control, 2 gallons of Batavia Kill water, and about half a gallon of Hudson River water to test, 8 mason jars, which we used for our bacteria, several water testing kits to test for all the other contaminants, glass beakers to heat water and mix, and also to mix the water with P&G powder, a graduated cylinder which helped to make the agar, and the agar itself.
So basically what our experiment is the way we're going to find which water filter works the best is we're going to test each of our water filters on both water from the Hudson River and Batavia Kill and the Catskills, and then we're going to test the water for a variety of chemicals as well as bacteria, and then by that we're going to determine which water filter was most effective, which would remove the most contaminants. So our procedure for the P&G powder was first we have to pour 190 milliliters of water from either the Hudson River or the Batavia Kill into a glass beaker. And then we take 1/3 of a scoopula of the powder, and then we mix it into our water and we let it sit for 5 minutes. We mix it for 5 minutes, and then after that we let it sit for another 5 minutes, after which the sediment and particles should have separated from the top water and settled to the bottom. You can see in the picture there's a lot of orange stuff at the bottom. That was one of our trials that we did, and according to the instructions, after waiting for these 5 minutes, the top water above all the sediment should be clean. So we used a syringe to extract the top water, and then we did our tests on them, and we'll explain our test later.
For the Sawyer mini water filter, we would pour 300 milliliters of water from either source into the bag, which is a part of the filter. We would screw on the pump and then turn the bag over and let the water go through the filter into a jar where we would test for chemicals and agar.
For boiling, we pour 200 milliliters of water from either the Hudson or the Batavia Kill River into a pot. This was one of the filters, or this was the filter that we had to do at home because we were not in school to test it. Then once it was hot enough that bubbles formed on the bottom and rose, or it was 100 degrees Celsius, we removed it from the pot and waited for it to cool down. Once it was cool enough, we poured some water into the testing canister for water testing and a little bit into a jar for bacteria testing.
In order to test the water, we poured the filter water into the canister until it was 1/4 from the top. Then we would dip the testing stick and follow the instructions from the water testing kit.
Our testing kits contained a variety of testing sticks which tested for different chemicals like chlorine, copper, iron, and things like that. So these sticks that we're talking about came from a testing kit, and it came with its own canister as well, where we had to pour the water. And our bacteria testing, so what we did, yeah, you do it.
Okay. We would soak some gelatin sheets in warm water, and while they were soaking, we heat 300 milliliters of tap water, and then add 1 chicken stock cube, which is used to make chicken broth and like in cooking, and also the gelatin sheets. Once the gelatin sheets have dissolved completely and the chicken stock cube is also completely dissolved, we can mix it up. We mix it, and then once it cools, it should be hard enough that like if we put water on top of it, the water doesn't mix in. And then we close it and leave it for 4 to 7 days, and then we see how much bacteria or how much mold has grown on the top. As you can see in the picture, in this one, there wasn't really any mold, so we would interpret that to mean that there wasn't enough bacteria for it to be dangerous.
Some of our errors and limitations include the fact that due to the coronavirus, we needed to complete some of our tests in different environments from the school lab, which included several different people's houses. We also did not wait the same number of days after swabbing the agar to check for bacteria because, again, of the coronavirus and changes of time and not being in school to check. But no mold grew on any of the tests. I hope that the time in between was not as significant. We also had to cut using one of our filters, which were iodine tablets, because we did not have enough time to test it fully. Another error that we had was that there was not an exact measurement for how much P&G powder we used for each trial. Rather, we just estimated about 1/3 of a scoopula. Bacteria tests were also conducted in different jars with different types of seal, and as such, the different amounts of air may have been allowed to come in between one jar and another. So it may not have been completely consistent throughout.
These are results from the Hudson water trials. We tested each water purification method twice, and the data points shown are an average of both trials. All of the contaminants except for pH level was measured in ppm, which stands for parts per million. The solid black line represents the tap water level. The dotted black line represents the Hudson water level, and the double dotted black line is when the tap water and Hudson water level were the same.
These are original levels, like before we did the filtering.
When there's no bars on the graphs, that's because they're all at 0.
These are Catskill water results. As you can see, the Catskill water is already very close to tap water. However, we still wanted to test both waters to ensure that the water purification methods were consistent.
Wait. So our conclusion and analysis, if you look back at both our Hudson River water tests and our Catskill tests, whenever we filtered the water, it either contaminants were either eliminated or it stayed the same, except for a few outliers. Filters either had a positive effect on the water or not at all. Now, this is very different from our hypothesis that the Sawyer mini water filter was going to work the best, because as we see in our results, all the filters work the best. All the filters work the same for each contaminant. No one worked better or worse than the other, except for a few outliers, as you can see. And we think that this is due to the abundance of errors which we encountered while conducting this experiment. So, for example, the incidence due to coronavirus and also our inexact measurements practically dictated our data. And because it is very illogical that something like boiling would have the same effect, due to the fact that boiling does not have any mechanism of removing sediment, while Sawyer does. So these results are very implausible, and I think that they can be blamed on our errors, and therefore we can't exactly draw a conclusion, sadly, from our data. We can't draw a conclusion from our data because of all the errors we encountered, sadly. But what we can say is that based on our testing, we know that whenever in a dire situation, you should always drink from a freshwater source, like the Batavia Kill, instead of the Hudson water, because in our original testing, the Batavia Kill was cleaner than the Hudson River water.
Another conclusion we came to is that all the filters just work the same if the errors didn't play as big as a role as they may have, and that our data was inconclusive.
These are our resources. Why not to drink dirty water? P&G, how does it work? 1. P&G, how does it work? 2. How are we testing for bacteria? Sawyer, how does it work? Toxins in the Hudson River and bacteria kills resources.
Any questions?
All right. Well, thank you very much, guys. It is not easy to go first, so we applaud you for that. Can you all see the participant list of people if they raise their hand, for example?
Yeah.
Okay.
Yeah.
Why don't we do virtual hand raising? If anyone has a question they'd like to ask, virtually raise your hand, and then you all can just call on them.
They are all muted.
They have the ability to unmute themselves.
Okay, never mind then. Avery?
Did you test the differences between running freshwater and like still freshwater, like a stream versus a pond?
That would have been
We did
interesting,
not
but
test
no,
the
we did not.
differences. We tested the differences between the Hudson water and a river in the Catskills called the Batavia Kill River.
Running water, just one was freshwater and the other one was not freshwater, and one had a lot more industrial pollution than the other, and the other one was kind of and that's still not as much pollution. That was the difference.
Harry, you broke up a bit there. Can you say that one more time?
And then our
Harry, just write it in the
tap
chat.
water.
Harry, just write it in the chat. We can't hear you.
So we compared all of our water to that.
Avery, we all take tap water as our control.
So water, but no.
Shira?
Oh, okay. So, do you think that the errors played like a big
big part in your like in your conclusion? Like, do you think, like, I don't know, was did your errors like make your data inconclusive or no?
Yes, we believe so. We don't think we came to an accurate. We don't think that our data is very accurate. We did realize that the Hudson River water was not effectively cleaned, and that Catskill water, the Batavia Kill River water was. But we don't believe that we can compare the three filters accurately because of our many errors.
Can you be a little more specific on that, Liana? Was there certain errors? In what specific way did those errors throw off the results?
Well, for example, we left, as Eva said earlier, we left the agar for various times, which may have allowed for some of them to grow mold for longer, while others, if left for that much time, may have grown mold. But because they were only left for a few, because they were left for less days, they didn't grow any mold. Well, possibly needing to complete the testing at home may have impacted it because it was a different environment and different people, stuff like that.
Also, like had an exact measurement lot. For example, when we were using our PG powder, we didn't know how to get exactly 1/3 of the scupula of the powder. So each of the trials might have been using a different amount because there was no way to exactly measure. And then also, like, the soil filter actually like had a leak on our second trial of it with the Hudson River water, and that could have contaminated our samples. So there's a lot of stuff like that that really, I think, had a large impact item.
Another error we might have made is that one test.
Also, there's in the chat.
Also, when testing the water, after seeing you had to compare the stick to the colors on the sheet, and that it might have been slightly off because that's just the human eye.
Yeah, in some cases it was like the color was not close to the sheet, and we had to make an estimate, just what was best, but that may not have been correct or effective.
I was going to ask, it seemed that you used different amounts of water between the two different filters, the Sawyer and the P&G pill. What was the reason for that?
The reason for that was that we needed more water to go through the Sawyer filter in order for it to effectively filter it out. But for the P&G powder, we didn't need as much water, so we used less because we had smaller, we didn't have unlimited amounts of water, so we wanted to try to conserve it just in case something went wrong and we had to restart our testing.
Was there, do you think it would have changed your results if you had done the same amount of water?
Okay.
I do not think it would have changed our results because everything would have been adjusted accordingly and it would have been the same. It would have been proportional.
Also, we only tested, we tested the same amount of water each time. We filled the testing canisters, which were all the same size. They were consistent until they were 1/4. They were full to 1/4 of an inch from the top. And so, although we may have filtered more water using the Sawyer filter, for example, we ended up testing the same amount. So I don't think that it was relevant.
Okay. Well, great. Thanks, guys. Does anybody have any last questions before we move on to our next group? All right, wonderful. So for the next group, that is Shira, Serena, Jude, and Roy, which whichever of you is going to be presenting, why don't you get it?
I'm screen sharing, so I'll do it.
Moment.